Fire in the hole. Okay, here is the second Sanwa chassis. It has not been recapped, reflowed, anything done. It has been working. Just going to double check functionality, and then we'll pull it out, start a cap kit and a reflow. We'll do like we did on Sanwa number 1 and get it back in the chassis, and then I'll do a little video on how I tune them for best picture. So, without further ado, fire in the hole. Oh, heard it come up. Love that sound of the static. Let's look in the mirror. What do we have? Oh, maybe I better turn a test pattern generator on. That usually helps. All right. So we have good raster, good picture. That's interesting. Down in that same lower corner that is adjacent to the one in the left monitor, have that same little purity. Maybe it's something to do with how close they are together. But anyhow, I do have them on an isolation transformer, even though this particular unit does not need one. Got a Bridgeport medical grade isolation transformer. I run it out to my own homebrew fire in the hole switch. Then into my multi-power cable. I've got everything from a set of alligator clips to various connectors that'll go on this 2-pin Molex to light up various monitors, and then of course the custom plug I built for the Sanwas. So let's get this chassis out and get it on the bench. You might ask, what's the best way to get the chassis out? We did our disconnects done. We discharged and pulled our anode. Got our neck board off, the ground off the board. Got our yoke undone. Got our wraparound power cord undone. Signal cable is off. And I think I already mentioned the remote board. So what I have found is with the one screw down here that holds the ground and holds the chassis in the bottom plate, we ease it back so we get it out of the front shoe and then out the side. Slide it right out the side, fold the neck board over, and there she is, ready to go. All right, we're here starting Sanwa number 2. All right, something I learned on the last one. Well, first of all, I like to get the metal chassis off. So that's out of the way. But I removed the flyback on the last chassis to get down in the flyback cage. And I also wished I had taken the time to remove the neck board so I didn't have it flopping around at the same time. A lot of caps on this monitor chassis. Oh, dinged it with my screwdriver. A lot of caps on this chassis, and a lot of back and forth, a lot of flip-flopping around. And this particular unit, I sometimes call myself the Flyback ENT, ear, nose, and throat, because if you look here, the flyback ear is cracked off. We can epoxy that back on. It seems like I do that a lot with these flybacks that have a screw through the heat sink holding the chassis and the flyback together. So we'll attend to that at some juncture. Let's go ahead and look at disconnecting our neck board. There we go. And both of these plugs I'm undoing are keyed just one way, so no real worries there. We know where the high voltage lead goes to the CRT socket, so there's no guesswork there. The only real thing to note is her G2 wire. we need to look and see where it goes, and just look at the orientation of the other components on the board and remember where we got to solder that back in. But we'll unsolder that. And well, that was in need of some help anyhow, because it fatigued off. I'll pull the stub off of it while I'm thinking about it. It's always easier to do with the fingers, but boy, it sure does hurt a lot. That's why the needle nose pliers get their work out. They'll take the heat where the old pink stubbies not so much. Okay, so we have freed our neck board. Now let's finish taking our metal rails to the chassis off, and we have freed our chassis. Now all we need to do is liberate the flyback. And I think we're going to start with the old solder again, since it's a fair amount of globular solder before we get down to the... Oh, that was a nice one. I can see where it cleared out around the hole. And for the most part, I run my iron, I don't know, 7 1/4, 750 degrees Fahrenheit. If it's a heavier lug or big heat sink, I might have to crank it up. Never could quite get into soldering down in the 600s. Things just don't heat up fast enough for me, and maybe I'm too impatient. But I'll have to say I don't lift too many pads and don't have too much issue. Now the fun part, where we got our screw out, we're going to kind of push and flex on the flyback here as we try to break some pins free. Grab my pliers, move a pin kind of in a circular motion to see if it's freed up from the grommet or not. Because it's like a little rivet on your jeans. It's hollow and it goes through the board. It's to provide extra strength and provide extra contact for soldering. Now some of those move, some of those do not. There we go, that one moved. So I've got those 3 moving. The 4th one's moving. This one does not want to move. So it needs a little more heat and persuasion. And sometimes you will just not get them to move. And one of your only options at that point is to heat and flex, heat and flex. I think we might have a good little bit of heating and flexing to do here. I'll put some solder to the pin itself so I transfer the heat better, but not wet it to the pad. A little more wick will help this one. Okay, so this is a stubborn guy right here. Okay, I was able to free that one up and then flex it just a little bit. So again, I'm putting a little bit of solder for good heat transfer to the pin itself, but I'm not letting it wet the pad and take it on down. And I'm using my thumb from the underside, applying pressure, flexing the board, but also trying not to break the board. So it's a balancing act, and it's kind of like billiards. Sometimes less is more. Sometimes a softer shot will do you better than just all-out blasting it. Alright, I did let that wet to the pad a little bit in hopes that the wicking action will help pull it up. Oh, I think I may have done it. That one wants to move now. Let's see if we can do the same thing next to it. Oh, but Steven, you're spending so much time pulling that flyback. Yeah. But ain't America great? If I want to pull a flyback to change 4 caps, by gosh, by golly, I can. But I truly think it eases the burden for me in the long run. Especially flipping this chassis back and forth so many times. Just lightening it up helps a lot. Got that pin moving. That one's moving. Ooh, I think we're getting closer and closer. Yep, did you hear that nice little crack? Let's rock this, and what pin isn't moving? This one. If everybody but him's a moving, I think we can just get a little heat. Maybe drop that flyback right on out. There it is. And there it is. Got our flyback out. So, for now, we've got a much lighter, much more workable chassis. Okay, we've got a cleaned up bench to work on. So let's do some more visual inspection before we get too froggy here. Our wafer ICs seem to be in decent shape. Not seeing anything burnt. Our ICs and heavy transistors look good. There'll be some component straightening to do like I did on the last chassis. Nothing really looks out of sorts. Oh, that's brittle. So that little cover over that transistor looks like it was rubbery silicone at one point, and now it's just crumbly wumbly. I think I'll unsolder that sand block like I did on the other one, straighten its legs up. Let's look underneath. Now, one thing I noticed from the factory right away is we had these same 3 modded places on the board from the factory and the other one, but these are coated in the silicon RTV kind of stuff that the caps are glued in with. So I believe the factory coated those. Just looking around here, we had that what was it, Q403 that I noticed on the other chassis had been hot and had brittle connections. Oh yeah. Yeah, those are ringed pretty bad. Let's see if I can bring this up to the camera so you can see it. We're right here. Find it a little more in center of frame. If I can get the light a little better on it. But those 3 connections on that transistor right there are all 3 cracked, ringed, and heated. I definitely think on a Sanwa PM1745 that is definitely an area that you should pay attention to. We're seeing a little bit of cracking over here at the degauss connector. I'll hit all the header pins for the various plugs. Now this board does look like it's seen some solder work. I don't know. I think these probably reflowed by somebody at some juncture. And maybe this transistor too, but they were a little globby on the other chassis. I guess this here at C814 looks disturbed, non-factory. We're kind of chunky with some solder joints over here where we've had solder added. Looks like our 3 color pots over here have been touched. So, I don't know. I think somebody has worked this board before. Oh, I know. The other thing that makes me think that. Ta-da. Somebody was in here and did something in 2014. Looks like March 6th, March 19th. This is March of 2026, so 12 years ago. Another tech was in here, it looks like. All right, well, we'll move on to doing a few caps and a little bit of reflow work. Trying to think if there's something unique I can show you that I either have to do or did on the last chassis. Oh yeah, like look here. This cap's been replaced because the glue's gone. Or at least it's been out and cleaned up. I would say both of these are non-originals. Glue's gone on this one, and they're both of the same color. Sungon, S-U-N-G-O-N brand capacitors. Not all off-brand capacitors are bad, but not all, but I would say most bad capacitors are off-brand. Just trying to make a funny there. But, no, I'd say we're in good shape. All right, let's talk about when you find an anomaly. Now, this is still Sanwa number 2. I touched up a fair amount of solder joints. Took a bunch of globs off and went back with some better solder. But I noticed this resistor was sitting a little funky. And if we look at it, look how that leg is shorter than that leg. The solder had been disturbed, and what I found was this trace is pulled up. This is one of those circumstances where I was talking about if you've got a component that's got some crusty legs, kind of like I see on some width coils or whatnot, you can use your spot sanding pen, your fiberglass pen, kind of burnish those legs up a little bit so that you're going to take solder. But what I think happened, this particular resistor looks formed and it has a squash spot right here on the edge of the leg, and that's where this one's broke off. That is for manufacturing purposes, so it only goes a certain depth into the hole in the PCB and then gets soldered. I think it got fatigued, broke off, and perhaps when they were doing the work in, what was it? I think that sticker said 2014. That was probably altered then. And then we're seeing the pulled trace and whatnot now. Now, the trace is not completely broken from, I mean, the pad isn't broken from the trace, but it's lifted from the board. I think that perhaps in this repair, they kind of forced that component in, maybe lifted it, maybe a little too much heat. Either way, I already cleaned it off with an alcohol swab, a little denatured alcohol and a cotton Q-tip. Kind of clean it up. Now I need to wick this hole clean over on this side. pad doesn't look the best either. I'd say both of these pads had a little bit of simian fornication going on to get to looking like they do. So my remedy to fix this is I'm going to put the component back in, legs straightened, legs burnished. See, that one stops on this side. I can't see. On this side, this leg stops where the wide spot or the squish spot is. This leg does not. It goes on through. And what I want to do is make sure that the component leg comes up through what's left of that pad. Now again, that pad is all still attached to the trace. It's not torn, it's just lifted. So I'm going to try a little something here where I'm going to clean my tip a little better, put a little bit of solder on, and I'm going to make sure I hold this pad down. There we go, it's got it laying pretty flat to the board. Let's resolder this side, flow that a little nicer. Let's see what we can do about getting enough solder on that to make it look good. Now I think that looks good. Now the only problem is any kind of force from this side of the board is going to continue to push that pad up. And continue to try to tear it off the board. We got all of our flux cleaned off with some denatured alcohol. Let's take our meter, prove out that we have continuity. Let's make sure that the trace itself is still indeed intact. Helps if I select continuity. Okay. Let's follow that one back to here. We got good continuity. So I do believe that trace is well intact. So we're going to try something. I don't know if any of you have watched some of those soldering videos where they are repairing like a cell phone board or something, and they've got tore up traces, and they put some of this coating on that cures with UV light. Just so happen to have a UV light, and I just have recently purchased this coating, this product. I'm not sure the tip is the way I want to go on that, but I do think I need the plunger. And let's take our Q-tip here, cut the head off, I'm looking to do here is to glue that connection to the board and seal it, so that pressure from the other side doesn't continue to push that trace and tear it off the board. So let's see what happens. See if this product is worth its salt or not, but it always looks cool. And got a UV light right here. Let's see what we can do to cure that. Now my guess is, like most UV light cure products, like windshield resins and whatnot that I've used before, I've got a video on my other channel. My other channel is called Jenkins Fixed It, where all kinds of little household projects, little automotive projects and whatnot is what I do on that channel. As of the making of this video, I only have one video on my other channel, aside from like the introductory video of "Hi, this is who I am." And it is repairing a Pac-Man bezel glass. And I used windshield resin and some clear Gorilla Glue on that project. But it took a good 10-15 minutes to UV cure that resin. So I don't know how long it's going to take to get this one. See, it looks to me like it's hardening up, but it's shrinking. It's getting a good skin on it. I can see it pulling away a little bit from the tip of the resistor sticking through. But this product is supposed to be a non-conductive conformal coating that protects and covers traces back up that have been exposed or had to be ground away for repairs or whatnot. I think it's going to work well in this application. Time will tell. I'm going to go ahead and cut away so you don't have to watch paint dry. And we'll come back when that's good and hard. Alright, I may have had too high hopes for that product. I'm not going to go all the way to sliced bread, but it's pretty nifty. By God, I think I'd give it Eggo waffles anyhow. My only gripe is I think it takes a long time to cure. I ended up propping the board up here and putting the lamp on it. Maybe I don't have a strong enough lamp, and that's why it's taken so long. But what I did do, and I don't think it will act as well for the strain relief like I had hoped. So what I did is I took a component leg. Let's see if I can get this up here where you can see it a little better. I took a component leg, snipped the littlest piece off, and laid it along the base of that resistor leg and tacked it with some solder. Now it has a mechanical stop that keeps it from pushing through the board, just like the squashed wide spot on this side of the resistor has. So I've given it mechanical stability, which I don't think the green stuff, at least it didn't cure fast enough to prove out to give me the mechanical stability. But it absolutely cures out for a nice insulator, and it looks good. I think, especially on a green PCB, it's going to blend in nice. But as soon as I heated it with the iron, I noticed a little bit bubble out. It made more of a shell, and it's still a little soft or tender underneath. And I think that might also have to do with the thickness at which I put it on. So I'm going to call it a win. It covers the pulled pad nicely, kind of glues and adheres everything and seals it under that coating. And I think with my mechanical stop on the leg of that resistor, I think we've got a solid repair here that's not going to be a repeat performance and tear that trace completely off. So I'm going to leave it sit with the light on it a little bit longer, let it cure some more. Now, as I was doing Sanwa number 2 here, I did find the same setup where we have C811, which could be a 4.7 at 250 or a 33 at 50, depending on your chassis design. This unit was also a 33 microfarad at 50 volt in the hole, and I put that value back in. Same thing with 441, could be a 4.7 at 250 or could be a 1 microfarad at 250. What was in our board was a 1 microfarad at 250. A couple other little anomalies. Whoever did the partial cap kit, and I say partial because it looked like only about a half a dozen of the larger ones were replaced. On the larger caps that were replaced, I did find a couple of funky voltages You know, it originally had an at 25. They put an at 63 volt in, which functionally is perfectly fine. But I think that would be a warning as you're doing cap kits, especially on boards where someone else has been in them before. You don't know for sure what they replaced and what they didn't. And if you do come up with some anomalies on what was what's in the board versus, say, what the Arcade Parts and Repair list says, I don't know. From my experience, I would probably lean towards following the instructions that come with the cap kits from Arcade Parts and Repair. They've been well vetted. They have put a lot of time and effort into putting these kits together. I truly think they're a time saver and a grouping of quality caps that would be hard to replicate on your own. So I was thinking there was one other little thing that I came across. Yeah, there was another cap in there that what was factory in the board was rated at 1 mic 50 volt, and what the instructions in the kit told us to do was a 1 mic at 250. I think that was C424, but I'm not 100% sure. And on Sanwa 1, I said that I could not find capacitor C113, 100 mic at 50 volt. Well, I found 113 on this chassis. And it is in the flyback cage, and it's this little polyester metallized cap right here. Again, just like the tantalums that are over here at 114, 115, and 116, I left those alone. I did not change out those caps just to put them at a different style. Since they're tantalum or metallized film polyester, I did not change them over to electrolytic, and I don't think that's the right answer either. But I do have cap kit to finish on this, but I got a little sidetracked and waylaid with that resistor project, and wanted to come back and let you know what I found. Again, not the best thing since sliced bread, but Eggo waffles at least. I think this would be a great product when we have some trace repairs where we got a burnt trace and can lay some fine wire like this, some frog hair on the follow where the trace used to be, connected up good, or if we have to use a little heavier gauge solid wire, be a nice insulator, help glue it down to the board and seal it up. Make a nice professional looking repair. I would say, aside from cure time, it worked for me just like it does for the Chinese cell phone repair videos where I've seen it. So that's my 2 cents. I'm going to finish the cap kit up and see you in a bit. Okay, here we are, Sanwa number 2. It's back in the CRT and frame. Let's see, we've got our high voltage anodes hooked up. Down here, CRT board is on. Our ground is connected. Our power is connected, which is back there, along with our degauss coil connection. We've got our yoke plugged in. We've got our neck board plugged in, got our signal wires in, and we've got our remote board. All right, got our test pattern generator. We'll turn that on, and let's see. Without further ado, fire in the hole. All right, I just went through adjusting this monitor a little bit and realized I wasn't recording. All right, so we saw it come up and start to give us our test pattern, and that's where the video cut out. So here's our test pattern straight up from the generator. Got a good looking checkerboard. Now I did go into horizontal position a little bit. A, check that it's working. B, moved it around. Sized up the vertical a little. But our white looks good, our black looks good. I hit and touched up the focus and the screen voltages. Now on our color bar chart, all of our colors are represented nicely. Our blacks look black, and our gray square down in the middle looks gray, and our white over on the right looks white. So I'm pretty happy overall with how that came out. We got some good looking linearity. Our vertical position could probably stand, if I can find vertical position. Vertical position. Let's hit our vertical size just a smidge. All right, that looks pretty good. Black looks black. Now this is a good, nice changing test pattern for various colors and not really getting your burn and whatnot. But overall, happy with how this monitor looks. So it's on to Sanwa number 3. I'll warn you ahead of time, Sanwa number 3 is completely untested. It's one of those mystery boards. I bought it on eBay, and I've also got all 5 of the upcoming Sanwas are mystery boards. They came from a gentleman out west that I bought a few, and I bought a couple off of eBay that were unknown quantities. So we're going to get them on the bench, visually inspect them, go over them. But Sanwa number 2's a win. Let's go for Sanwa number 3. Thank you for joining me at Fro-Dog Arcade Repair. I hope you enjoyed the video, found it useful, or at least entertaining. Please subscribe below. Like, follow, and share with your friends. And remember, fire in the hole.